Aloha, Richard Halverson here. This is ITS148, and today I'm going to do assignment 3. All right, it's the sort comparisons assignment here. So what we're supposed to do is we're supposed to implement selection.py, bubble.py, and merge.py. We're supposed to grab the Python programs from these programs here and just get them running on our server, making sure that we put this in front of the main program code, so I can, when I test these things, I can bring them in as modules and just test the method. I just want to test your methods. Here you actually have to write, oh no, here you have to convert an algorithm. They give you the algorithm in an algorithmic language that looks very much like C or Java or one of those kind of languages that uses curly braces to delineate blocks. In Python, we indent to indicate a block. So anyway, we're supposed to implement these 3, and then we're supposed to implement this program to compare execution times. And I give you this part of it, and you're supposed to duplicate that under here and under here, except for you're testing the merge sort. Or, you know, here we test the selection sort, and we want to test the bubble sort and the merge sort. And they will be brought in, you know, like this. I don't think this should be a PY, should it? Yeah, I think that's wrong. Gee, I better fix this. Let's see, let me refresh this. And this is what it should be. So you, for 3.2, you copy this into a program named compare.py, and then you just finish writing the code, because you want to see how long it takes for bubble sort to run and how long it takes for merge sort to run. And what this program does is it generates a random array. This program generates a random array, and then it tests how long it takes for each of these to sort that random array. And you can enter in as big a number as you want for how big that random array can be. And so, you know, you enter in something like 5,000 or, you know, 7,500 or 10,000 random numbers, and then these sort, and they sort them. These and you're able to compare as the array size gets bigger. You're able to see how much longer it takes for each of these sort programs to execute. All right, so let's do this assignment. So I go to my cPanel, sign in, log into my cPanel, and go to my file manager, and go to assignments, and I gotta create another folder called 3. And inside 3, what do? Inside 3, create selection.py, bubble.py, and merge.py. So let's do that. Folder bubble.py. No, not a folder, a file. File bubble.py, and another file called selection.py, and another file called merge.py. So let's, and then start with selection 16.2.1. Let's see, 16.2.1, which is 16. Okay, selection sort. Okay, so you should go through this and try to understand how it works. Okay, it basically, it goes through and finds the smallest. It goes all the way through and keeps on picking out the smallest one and making a list, keeping on pick. He takes a list, finds the smallest one in the list, takes that one out, puts it over here, goes to the list, finds the next smallest one, puts it, okay, takes the next smallest one, and so on. And in the end, it's got all of the elements in order. So that's how selection sort works. So we're supposed to copy this, copy it, and we're supposed to go to the file manager and open up selection, edit, paste, and save. So we can run this. We can just run it. Let's go to file manager, scroll down to advanced. I'm going to right click, open link in new tab, and wait till it opens up. CD to assignments /3, oops, 3, and ls-l, and these are my 3 programs. And let's try selection. Python 3 space selection.py, and it takes an unsorted list and sorts it, lo and behold. So anyway, we're supposed to now indent the main part of the program in this. So I'm going to take this and I'm going to copy that. This is so selection sort numbers can be imported from selection.py and used by another program. So that's how I'm going to test it. So I'm going to go back to here and I'm going to go right up here and I'm going to paste this like right here. And then I got to indent my main program. So I'm just going to collect all this together and I'm going to tab. Okay. Now, this runs the same as it did before, but it's got this here, and what this does is only if it's the main program. You know, here it's the main program, it's the one I'm calling. Only if it's the main program does this part run. Other times when I want to grab this whole thing, and I want to execute because I want this to execute. I want this to execute because I've got some other program that I want to have access to this particular method here. So I pulled this whole thing in as a module, and basically what the Python interpreter does is it just executes this thing. But if it's not the main program that's executing it, then this will not execute because I don't want this to execute. Right? I just want this part. Okay. Anyway, so that's what that is there for. I know I've told you that before. All right. So let's do the same thing for what's next? Bubble. In Bubble, we've got this one. Oh, here we actually have to do something because we have to convert from the algorithm to the main program. Okay, so 16.3.1 in Bubble. So let's go over here and I'm going to do a lazy now you all got to know how to do this, okay? You all got to know how to 16.3.1. 16.3. Okay, so this is bubble sort written in this algorithmic language. It looks a lot like many languages. This actually would probably work in many languages. definitely worked in JavaScript. Anyway, so let's almost would. Let's go here, and I'm going to paste this here. Now I got to convert this to Python. I got to convert it to Python. All right, so watch this. Okay, this is the I'm initializing a new method. So what is that? Well, it's going to be a def space, and then really this is fine. These are two parameters coming in, but at the end of this definition we have a colon. Okay, and then we don't have this squiggly brackets, okay? These squiggly brackets. Well, these squiggly brackets take the place of indenting. Okay, now you notice that it's indented anyway. Okay, you notice that this indentation looks just like the indentation of a Python program, but it turns out in all the other language, by the way, in all languages we indent, but in all languages the indentation doesn't matter. In fact, we can have this program be one big long string. Just make sure we put all of the characters in the same order. And so these curly braces here, that encloses the outside. Okay, so we can just take these out because we're indenting. The indentation is good enough for Python. And then we have a for loop, and this looks like it goes up to numbers. Okay, so it's a number says -1. So this is just for I in range parentheses this whole thing. Okay, and we don't have to put the I++ because it's going to increment just one at a time anyway. We don't have to put the 0 because it defaults to the 0. We do have to put this is the upper limit -1, the upper limit minus. We want it to go up to not the last element, but the second to the last element. So we put the range is going to end up being the index of the second to the last element. Anyway, so that looks like a perfectly fine for loop in Python. Let's put a colon there, and again, we don't need these curly braces. And here, same thing. For in this is -I-1, so this can be different. Can we still do? I think we can still. Yeah, we can still do that. J in and this is a range again. I think we could just do this. I think that will work. And we do another colon. Get rid of the squigglies. And we can get rid of all these squigglies. And if numbers, we don't need parentheses here. This can be a colon. And we don't need that last parentheses there. So if numbers j is greater than numbers j+1, then in Python we don't. All this is doing is exchanging. It's exchanging numbers j with numbers j+1. It's just exchanging them. So the way in every other language, the way you do that is you have to have a temporary variable. You put one of them in the temporary variable, and then you put the other one in that one, and then you put the temporary variable back into the second one. You don't need to do that in Python. You can just do a double. Here you do a temp of numbers. Comma numbers +1 is equal to numbers +1 comma numbers. Just this over here, and you don't need this. Okay, so this I'm quite sure is what it would look like in Python. Let me just check my notes here because this seems pretty simple. Yeah, no, this is it. All right. Anyway, so then we also want to throw this underneath it. Copy, paste, throw that underneath it. And we aren't calling selection sort, we're calling bubble sort. Oh, I guess we should name it like this. Is that what we do? I guess that's what we do. And copy this to here. Oh, and this only has one number size. What's number size? Number size is we don't have number size in here. We got to put number size down here. Why does it do that? That's all right. You got to re-indent. Dent. And I got to put number size equals the length of numbers. All right. And I got to get rid of this parameter. Okay, so now I've got bubble sort, and it figures out number size inside here, and then it goes ahead and does it. And that's that. So let's see what this looks like when I run it. Bubble.py. Line 3. It doesn't like that. What am I saying wrong here? Error, numbers size is not defined. Well, I didn't mean numbers. I meant number size. I call it numbers of size. Well, I'm gonna call this number size. That's what I call it there. Whatever, it doesn't matter. It's got to be correct. It's got to be the same. And I'll go back here and run this again. And looks good. All right. Now I got to do the same thing for merge sort. So that's in 17.2 in the main part of the program. And then put this there. So I can, okay, so let's go to 17.2.1. 17.2.1. You got to read this. You got to go through all the checkboxes, and all you're doing is it's explaining all these different kinds of sorts, and then it explains how long it takes for the sort to execute as the list size increases. That's the important thing. And these are called fast sorting algorithms. All right, so anyway, we're supposed to go to merge sort. And I think I might have some, do we have some Python here or something? Looks kind of Python-y. Ah, look at this nice big long Python. Oh, here we go. Very good. So let's take this. Shift, Control, copy, and go to merge. And paste. And save. And do that if then thing. this thing. Right here. And take this all the way down to here and tab in. There we go. Let's save this. So this is how you call it, how you call merge sort. You call it when you give it the array, and then you give it the lower index. This is kind of like binary sort, a binary search in the last video, where you need to give it the indexes of the lower and the upper indexes of the subset of the list that you're in this case sorting. So anyway, let's run this and see what it looks like. So go to I'm going to go back to terminal, and I'm going to do Python 3 merge sort merge.py. Okay, and that looks like it's working. All right, so what does the assignment say? Is that all we have to do? That's all we have to do. All right, I'm going to see how this looks. Where's my, oh, here it is. All right, this one, what does this look like when I run it? Okay, well, that's good. What is this? Oh, I should. Anyway, so I didn't get any points. What did I not do? Now this happens when it actually interrupts. It actually interrupts the program and it doesn't let it finish. Let me just run this again. Okay, I had to increase a timeout period. So if any of you are doing this, running any of these grader tests, and you get an error that looked like what you just saw, then just try to run it again. And if you get the same error again, and you're pretty sure that your program is correct, then contact me. Then send me an email. So all right. So the way this sorts test works is it actually creates a random array of 7,500 elements, and then it sorts them in ascending order, and that's one data set, and then it sorts it in descending order, and that's the second test. Okay, and so and then it runs selection sort, and then it runs bubble sort, and then it runs merge sort. And it starts by running it on the already sorted data. So you take a sorted list and you run the sort program on it, and you see how long that takes. Okay, it's already sorted. So 7,500 records. Selection sort takes 1.79 seconds. Bubble sort takes 2.48 seconds. And merge sort takes 0.04 seconds. Okay, then I run it on the unsorted list. It's worst case. It's completely unsorted. In fact, it's sorted in reverse order. So the selection sort takes 1.81 seconds. Takes a little bit longer, but just virtually the same. Bubble sort takes 6 seconds. Okay, the bubble sort on the already sorted list took 2.5 seconds, but on the worst case, the reverse ordered sorted list, it takes 6 seconds. And merge sort just takes 0.04 seconds again. And these are actually how much more the unsorted list takes than the sorted list. And for merge, for selection sort, it's about the same, 1-to-1. Bubble sort took 2.5 times longer when the list was completely unsorted, and merge sort took the same in both cases. This here just tests to see that the results are correct. Okay, so all selection sort and bubble sort and merge sort, when it was done sorting it, it sorted it correctly, and so of course these have to be correct. If these are not correct, if any of them is a 0, that means your sort algorithm doesn't work. That means your sort program itself doesn't work. When but on a list this size, selection sort should be about the same, and should be around, it should be like more than, it's this one and this one is selection sort. It should be around, it should be over 1. It should be greater than, should be much greater than merge sort. Merge sort is less than 0.01 or less than 0.1. So merge sort, both of them, they all have to be low like this. And then bubble sort has got to be, about 2.5 times bigger for the completely unsorted version as with the sorted version. And bubble sort, of course, is the worst. So so that's the profile. That's what it's got to look like. And if I were to make this bigger, the bigger I make this, the bigger difference this becomes. This bubble sort just takes way longer, and you'll notice that. All right, so that's what the profile has to look like, and that's how this looks to see if the sorts sort correctly, and that it gets that information from this, and then it checks to see that they behave correctly, that we compare them and make sure that. Now, there is a shortcut to bubble sort. I just want to quickly mention this. Bubble sort starts at the it takes as many passes through the data as there are elements in the data. Okay, and so what it does is it takes a pass through the data, and it's basically bubbling the largest element down. Okay, so it takes a pass through, and if ever there's an adjacent pair that's out of order, it exchanges them. So it keeps on exchanging down, and then takes another pass through, takes another pass through. Now, if it takes an entire pass through, this is an entire pass through. If it takes an entire pass through, and there were no exchanges, then we know we're already sorted. Then we know it's all done. So what we can do is we can count exchanges. Okay, so to count exchanges, we can do, first of all, we say num ex, let's call it number of exchanges, equals 0. And then each time we do an exchange, this is an exchange. So each time we do an exchange, let's increment num x. And if we get all the way through this loop here and we never incremented or we never exchanged, in other words, if num x equals 0, then we're done. I think it's break. Yeah, then we're done. So so for the perfectly sorted one, we should see this is the sort. This is how long it takes to bubble sort an already sorted list, and this is how long it takes to bubble sort a list that's completely unordered. Okay, that's ordered in the opposite way. So each pass through, you're exchanging every time. You're exchanging everyone. Okay, that's all you do, because you have to exchange all the big ones down to the bottom and all the small ones up to the top. So let's see what this looks like with this nice change here where we're counting exchanges. It should affect the already sorted one, but it's not going to affect at all the completely unsorted one. So I saved this. I saved it already, and let's run it again. Okay, so it's done. And you notice that the bubble sort now, okay, these are pretty close to the same. But the bubble sort now was 0 for the already sorted list, and it was 693 for the unsorted list. And we see that it is this amount. This is how much longer it takes. You know, 10,112 times longer with a completely unsorted list. All right. So anyway, so that's part one, the sorts list, the sorts test, and then next I ask you to finish this thing here. Finish this compare execution times. And so let me create a new file here called, oops, let me refresh this. That's the test program that gets uploaded to your account, and when it's done, it deletes itself, so you don't see it now. Anyway, so I have to create a new file called compare.py. Edit, and let me copy in this. Okay, and so the way this code works is it asks you an array size, and if the array size that it asks, if you say something that's less than 100, then it actually, you know, displays out the unsorted array, and then after the thing is done sorting, it displays out the sorted array. And so presumably, if you're still testing to make sure your stuff works, you can see actually the numbers that it generates and what the numbers it tries to sort. So, but if the size you give it is bigger than 100, then it doesn't display out the arrays. It just does it and tells you how long it took. Okay, so let's take this. Let's copy it over to here. This copy, paste, and generate the numbers. Here, this generates the random array into here, and this displays out the number of elements in the array. So it's all it displays. And then for each of the sorts, it first of all, it makes a copy and then sorts the copy. Okay, it sorts the copy, and that way it keeps the original, because you're able to use the original again for the next sort and for the next sort, because you want to make sure the arrays are the same when you're comparing. Okay, so this is selection sort, and I'm just going to copy this section here, copy, and I'm going to put it here and here, and I got to change this to bubble. Okay, so this. Okay, I just realized that if you go back and look at the other bubble, okay, yeah, so it's you, this is different than the description of the, this is different than this description here. Anyway. You may have to mess around. You may have to mess around with the name, with the parameters. Okay, I think you can either. Oh no, wait a minute. I'm confusing this bubble sort with the binary search assignment that was before. That was earlier. Okay, never mind. All right. Okay, so let me go back to doing compare, and I've done bubble. Do bubble sort, and I want to print. This has to say bubble. Make sure you do this, because I look for this, and I look, and this has got to be right. Merge, and this has got to say merge. Okay, doesn't, it thinks you don't have it, and so anyway, so when you run this now, you can run it, terminal, and you just say Python 3 compare .py, and let's try an array size of 50 just so you can see it. And this is kind of a mess, but array size of 50 says 50 elements in an array. It does the unsorted one and then the sorted one, and it says how long selection sort took. Only took that long. How long bubble sort took. It only took this long. And it merge sort. Didn't work. Merge sort didn't work. Missing 2 required positional arguments. I and K. So I need to. I'm not done with merge sort. Merge sort. Oh, it's got merge. Okay, I and K. Wait, this is. Oh. Anyway, so let me just change it. Where's? Let me just change it in here. I gotta add some parameters here. 0 and length of numbers, probably -1 because it's probably an index. Let's see. Length of the numbers -1. Okay. All right. That should fix it. So I have to do that for merge sort. Now let's see if this works. Terminal. Same thing. Let's do 25. What the heck? Smaller. Okay, so I got an unsorted, unsorted, and assorted. Selection sort takes that little time. Bubble sort takes that little time, and merge sort takes that little time. All right, so let's do 5,000. Selection sort takes that, bubble sort takes that, merge sort takes that. Let's do 10,000. Yeah, so bubble sort really starts to take longer, and merge sort stays consistently fast. Okay, so that I think that. Oh, let's run it. We got to run on, see if this one works. I wonder if I need to extend the time for this one too. No, I don't think I do. This one. Sort comparison test. All right, very good. And we see that it looks for whatever, and it says that was exists. Anyway, I got all the points. All right, so that takes you through that assignment, assignment 3. And hope this helps. Thanks for watching.